everybody. Today we're going to do section 8.2. And in this section, we're going to graph still parabolas, quadratic functions, but now we're going to add a c at the end of our equation. So our equation is going to look like f of x equals ax squared plus c. So the c is going to change how our graph is going to look. Let's see. When our c is greater than 0, or in other words, when c is positive, that means that this is going to be a vertical translation of c units up. We're going up because the c is positive. So instead of now the vertex being here at 0, 0, it's going to be moved up to this point right here. And the c is going to be where it's going to end up. That's how many boxes we're going to move up on the coordinate plane. If c is less than 0, or in other words, if c is negative, then that's going to be a vertical translation of c units down. So instead of the vertex being at 0, 0, now it's going to move down c units. And again, it's going to move down here to be at that c value. Let's take a look at example 1. So in example 1, we're going to graph a function that has x squared plus c. So there's no a in front of this one. I don't have to worry about the a. Let's just worry about this minus 2, which is our c. And then we'll compare the graph to the parent function. So to graph this, we're still going to make a t-table of values. We're going to put 0 in the middle for our x's. And because there's no number in front of this x squared, we're just going to go by 1s. So we went down by 1s and up by 1s. You can take these x values and plug them into your equation up here to find your g of x or your y values down here, or you can put the equation into your graphing calculator and do second table to get these values as well. Let's just see if we do it in our head. So if I plug in negative 2 squared is 4, minus 2 is 2. Negative 1 squared is 1, minus 2 is negative 1. 0 squared is 0, minus 2 is negative 2. And then remember that the y's here should be symmetric. So if this first value is 2, the last value should be 2. If the second value is negative 1, the second to last value is negative 1. And then this point here is the vertex in the middle. Okay, let's plot the points. We're going to plot the points. Here is the new points on this blue curve. So we have negative 2, 2. Negative 1, 0, negative 2, 1, negative 1, and 2, 2. And you draw that smooth curve that connects them to form this parabola. Okay, you can see that this black function here, this is the parent function, f of x equals x squared. So now we can compare the two. Now there is no a value in front of this x squared, so the shape of the parabola didn't change. There's no stretch, there's no shrink, and there's no reflection. Both the parabolas are pointing up. But look at where the vertex was in the parent function. Look at where it is now. It moved down too. So that means that both graphs open up. They have the same axis of symmetry. The vertex is now at 0, negative 2, which means that this is a vertical translation of 2 units down of the graph of f. Let's listen to Big Ideas explain another example.
Graph g of x equals x squared minus 4. Compare the graph to the graph of f of x equals x squared. Begin with the graph of f of x equals x squared. Then make a table of values. Substituting negative 4 for x in the function g gives g of x equals 12. Similarly, when x equals negative 2, g of x equals 0. When x equals 0, g of x equals negative 4. When x equals 2, g of x equals 0. And when x equals 4, g of x equals 12. Next, plot the ordered pairs negative 4, 12, negative.
I just want to point out that in this t-table, they went by 2s, but you don't have to. You could have gone by 1s because, again, there's no number in front of this x squared. But that's up to you. You decide what you want to go by in your t-table.
2, 0, 0, negative 4, 2, 0, and 4, 12. Then draw a smooth curve through the points. Both graphs open up and have the same axis of symmetry, x equals 0. The vertex of the graph of g, 0, negative 4, is below the vertex of the graph of f, 0, 0, because the graph of g is a vertical translation 4 units down of the graph of f.